In question 28, it says the annual precipitation amounts in a certain mountain range are normally distributed with a mean of 109 inches and standard deviation of 10 inches. We want to know what is the probability that the mean annual precipitation during 25 randomly picked years will be less than 111.8 inches. So the mean and standard deviation we have is for the individual precipitation amounts. So now we want to know about the distribution of the mean. So the mean of sample means is just going to equal the mean, and that is 109, so that's straightforward. The standard deviation, or the spread of the sample means, is the standard deviation of the original data set distribution, the standard deviation for that, divided by the square root of the sample size. So in this case, the standard deviation for the individual values was 10, and this is over 25 years. So we're going to divide by the square root of 25. So when I put this into the calculator then, I'm going to find Normalcdf. I'm going to use that Normalcdf function because I'm looking for a probability. So with the Normalcdf function, I need my lower limit, and it says we want to know the probability the mean will be less than 111.8. So that means there is no lower limit, and I'm going to put in -1 E99. That's often the default that's already in there, but if it's not, you can type that in. And then the upper limit is the 111.8. The mean is 109. And the standard deviation is 10 divided by square root of 25. And you can just type it in just like that. And when I calculate this, I get 0.9192. So that's my answer for that problem. Now in question 29, it says the scores on a certain test are normally distributed with a mean score of 60 and a standard deviation of 5. And we want to know what is the probability that a sample of 90 students will have a mean score of at least 60.527. So again, we want to find the probability about the mean, so the distribution of the sample means has a mean that is equal to the original mean, and the standard deviation of the sample means is the standard deviation divided by the square root of the sample size. So in this case, that's 5 over the square root of 90. So to put this in the calculator, again, I'm going to do Normalcdf. And let's see, what's my lower limit? This says at least 60.527. So that's my lower limit, 60.527. My upper limit, there is no upper limit, so 1 E99. Mean is 60, and the standard deviation is 5 divided by the square root of 90. when I put that into the calculator, so I've got 0.1587. Okay. And now for number 30, it says, assume that women's heights are normally distributed with a mean of 63.6 inches and a standard deviation of 2.5 inches. If 90 women are randomly selected, find the probability they have a mean height between 62.9 inches and 64 inches. So again, I look at what is the mean for the original distribution of the heights, and that is 63.6, and my standard deviation is 2.5. So distribution of the sample means mu sub x bar is just mu, and that is 63.6. Standard deviation is going to be smaller than it was for the original distribution. Let me put in the formula there. This is sigma divided by the square root of the sample size. So that's 2.5 divided by the square root of 90. So again, when I put this into the calculator, I'm going to do Normalcdf. And my lower limit is 62.9. My upper limit is 64. The mean is 63.6. And the standard deviation is 2.5 divided by the square root of 90. And let's see what that turns out to be. And that turns out to be 0.9315. And that's a little bit different from the answer here, and they may have used some slightly different technology in order to get that answer. So this is certainly the closest to 93.18. So that's my final answer there.